All right, so rectangular to polar on the calculator again. This time, let's say I'm asked to give the answer in radians. Okay, so again, just returning to a couple of questions I would have done in a previous video where I did it out by hand, and I'll do them on the calculator now. There is another odd little thing the calculator can throw up when doing these in radians. We'll come to that in a second, but first, you can just do it like we did earlier. So 2 root 3 xy 2, second function 8, and I get 4 and 30. Okay, so when I did this by hand, I got a modulus of 4 and I got an angle of 30. So if I was asked for it in degrees, 4 cis 30 is my answer. If I'm asked for it in radians, just convert 30 into radians. Okay, so remember to convert into radians, it's multiplied by pi over 180. So if you do 30 multiplied by pi over 180, there's your 1/6 pi, or pi over 6, as we more often write that. All right. You can also do that conversion on the calculator once you get to 30. So if you have your 30, and it's this one here above the decimal point, so second function, and it's the d over g, and it's telling you that that is 1/6 pi, or just pi over 6. All right. We can also do it in radians mode from the start, and this is where the strange little thing comes up. So set up 0, 1 to go into radians mode. So just 2 root 3 xy 2 again, second function 8, and we see here that it gives me the modulus of 4 that I'm expecting, but instead of giving me pi over 6, it gives it to me in decimal form, just like we saw with the modulus when it would sometimes give it to me in decimal form when I wanted it as a surd. Okay, now if we think pi over 6, pi is about 3.14, so 3.14 over 6 will be a little bit more than a half. So I do have the correct angle here, just not giving it to me in the form I want. Getting it in the form I want is very like when I want to change the modulus from a decimal to a surd. Okay, so when I wanted to change the modulus, it was above the RCL. There was a green X. Okay, the X there is where the calculator stores the modulus. It's above STO where there's a green Y. That's where the calculator has stored the argument, the angle, the theta. Okay, so if I do alpha STO, a Y comes up, and then just equals, and I get the 1/6 pi, or pi over 6. Okay, so I don't need to mess around with squaring and square rooting like I did with the modulus. Once you ask it for Y, it cops onto itself and gives it to you in that form rather than as a decimal. Okay, I'll just do one more of these. So I did minus 4 root 2 minus 4 root 2i. So this is in radians mode, so let's do it that way first. So minus 4 root 2 xy minus 4 root 2, second function 8, and I get 8 as my modulus, which is what I expect. I want my angle to be minus 3 pi over 4. Okay, I get minus 2.35. Look, you want a pi in your radians. You don't want something like minus 2.35. Okay, so even if we didn't have this, we'd know that's not what we want. Okay, so again, it would just be alpha STO equals, and there's minus 3/4 pi, or minus 3 pi over 4. Okay, we could also do it, as I say, in degrees mode. So set up 0, 0. So minus 4 root 2 xy minus 4 root 2, second function 8, and there's my 8 and my minus 135 degrees. Multiply that by pi over 180, gets you minus 3 pi over 4, or minus 135 second function decimal does it for you as well. Okay, so remember, once you're down in these two quadrants, as long as you put these in as negative numbers, and the calculator will default to giving you negative angles down here, positive angles up here. You don't need to worry about it like we did so much when we were doing it by hand.